Hello and welcome to Mr. Davis's classroom. This is Algebra 1, Lesson 7-6. Today we're going to talk about exponential functions, and we're going to evaluate and then also graph exponential functions. Here is a warm-up for you to try. Please try this and complete it before moving forward. Okay, now an exponential function will look like either one of these two, where it's kind of a sloping line that grows pretty fast. The equation that belongs with these graphs is found right here, where we have y equals a times b to the x power. Few things. B is called the base. X is the variable in the exponent spot, and then the a value is out front. So when I look at this one here, the a value would be 1, b value would be 2, and then the x would be x. Here, a value is negative, or a value is -1, the b value is 2, and the x is still x. And over here, same thing. The only difference is the b value is 1/2, and then the one that's pointing upwards is a value of 1. The one pointing downwards is an a value of -1. Well, let's try some of these, see if we can get the hang of it. All right, so does this table or rule represent an exponential function? And then explain. Well, looking at this one right here, right, we have our x values, okay, and then we have our y values. Anytime we have an exponential function, we should see something happening in the pattern of our outputs, right? Now, we go up by 1 each time, and here if I look, these are all increasing by a factor of 3. Okay, all increasing by a factor of 3. Now what this tells us is that 3, since we're increasing by a factor of 3, that 3 is my b value. Since we have negative signs, it tells me that my a value is a -1. If I plug all these in together, I get y is equal to a -1 times 3 to the x power, or more simply, just -3 to the x power. And that gives us this exponential function. So is this one an exponential function? Yes. It's got a increasing by times 3 each time. The a value is a -1, giving us an exponential function. What about this one right here? Is this an exponential function? Well, if we look at this at first glance, you might think, yeah, it's an exponential function. But the difference is an exponential function looks like y equals a times b to the x power. Where should my variable be? Where is my variable actually at? My variable should be in the exponent's place, not in the base. This is a no, because the variable should be in the exponent's place. This one's actually called a quadratic. All right, here's 2 for you to try. All right, try these, and then move on. All right, so here we have a word problem which talks about population growth of 30 flower beetles. The population doubles each week. The function f of x is equal to 30 times 2 to the x gives the population after x weeks. How many beetles will there be after 56 days? Well, what we need to do is we need to plug in the x value. However, this says the beetle population doubles each week. What did they give us? They gave us days. So we need to convert that days to weeks really quick. And I think that's 8 weeks. Okay, so we're at 8 weeks. So at 8 is going to be my x value. So I'm going to plug that in. So I get 30 times 2 to the 8 power. Okay. Then we need to use calculator to figure out 2 to the 8th as 256. 30 times 256 is 7680. So after 8 weeks, or after 56 days, we have 7,680 beetles. I would say that's probably an infestation. But let's write it in a gridded response here. So it goes 7 6, 8, 0. 7, 6, 8, 0. All right, sounds good. All right, here's one for you to try with rabbits, tripling every half a year. Now, since it says tripling every half a year, be sure that whatever you plug in for x is written in half years. So how many half years are they asking for? Okay, now it's time to graph an equation. Now, we could graph any equation that we want by plugging in points until we see a pattern. Well, we know that the exponential function already has that pattern where it kind of starts off slow and then it grows really quickly. So let's figure out where our points need to go, and then we'll plug those in. So we have -2. If I plug -2 in to my equation, I get 3 times 2 to the -2 power. So 3 times 2 to the -2 power gives me, let's see, what did I plug in for x? I plugged in -2 for x, and I get out 3/4 for y. And then if I plug in -1 times 2 to the -1st power, I'm plugging in -1 for my x. If I plug -1 into the calculator, I get 3 halves. If I plug in 0, I get 3 times 2 to the 0 power, which is going to be 0, 3. If I plug in 1, I get 3 times 2 to the 1st power, which is 1, 6. And if I plug in 2, I get 3 times 2 to the 2nd power, which is 12. All right, so let's plug in these points to see if we can come up with a nice pattern and then fill in the pattern from there. So we have -2, 3/4. That's about there. Then we're at -1, 3 halves, which is going to be 1.5. If I plug in 0, 3, gives us that point, 1, 6, and finally 2, 12. Now I think we can see the pattern happening here and draw our exponential graph. All right, here's a couple for you to graph. Make sure you graph these before moving on. Problem 4. So we need to come up with a graph that represents this equation, which talks about the percentage of the original area of a map after zooming. And we see here we have a map around Miami where we zoom, and then we zoom again, and we see less and less area in more and more detail. So let's graph one of those first. Let's put in some x coordinates. We'll do 0 through 3. And we want to plug each one in. So I'm going to have 100 times 0.25 to the 0 power. That is going to give us 100 for our y. So we have our x's and our y's here. If I plug in 1, I get 100 times 0.25 to the 1st power, which is going to give us 25. If I plug in 2, I get 0.25 to the 2nd power, which I think we're going to have to use a calculator on this one, but we get 100 times 0.25 squared, which is going to give us 6.25. And then if we plug in 3, we get, let's see, 100 times 0.25 to the 3rd power, and we get 1.5625. Now remember, this gives us the percentage of the original map. So this starts off, if we do 0 zooms, we're at 100% of the map. 1 zoom, we see 25% of the map. 2 zooms, we see 6.25% of the original map, and after 3 zooms, we only see 1.5% of the original map. So let's plug those in. we'll use Wizard. Let's see. My x values have to go from 0 to 3. So 0 to 3. My y values go from, let's see, my biggest number is 100, my smallest number is 1.5. So I need to go all the way up to 100. A little bit more. There we go, and let me get my step a little bit bigger. We'll go to tens. All right. Here we go. So let's see what this one looks like when we graph it. So I'm at 0. I'll graph this in blue. 0, 100. So 0, 100, right there. 1, 25. That's 1, 25, quite a bit smaller. At 2, we have 6.25. 2, 6.25 is about there, and then at 3, we're at 1 point something, 5. Looks like that. So that's our exponential curve regarding the percentage of area you can see on a map. Okay? And again, what did we do? We plugged in numbers. We plugged in numbers to get the graph. All right, so here's another one talking about the same computer program. So we're going to graph that one. So make sure you graph that one before moving forward. Here's your homework, page 450. Thank you for visiting Mr. Davis's classroom, and enjoy.